Alright, let's talk about something you probably use every day, but never really think about. No, not your smartphone. Not your car keys. I'm talking about that big, shiny cooking pot sitting on your stove. Ever wonder where it came from? You might think a clean lab, but truth is dirtier, hotter, and more interesting. Starting in a heap of junk. This is industrial-scale reincarnation, a grimy, sweaty, vital cycle. The metal is aluminum, lightweight, conducts heat beautifully, and it won't rust. Best of all, it can be reborn again and again, with massive energy savings. The journey begins in the yard, a sprawling metallic landscape that stretches forever. Raw material arrives by the truckload, from every corner of life. Baled cans, old gutters and siding, window frames, even engine blocks. First, a rough sort with a giant claw that never misses. The goal: remove non-aluminum junk fast. Steel is the big one. It can ruin a melt if it sneaks in. Trained eyes spot copper, brass, stainless, and iron in a heartbeat. It's demanding, high pressure. Mistakes are expensive later. Then, the eddy current separator adds finesse. Spinning magnets induce a kick. Aluminum literally jumps away. Junk drops. Good stuff is cleanly split. The journey from discarded scrap to premium cookware begins not with fire, but with brute force. Before we can even think about melting, the raw aluminum is shredded. This isn't just about making large pieces smaller. It's a violent, mechanical purification. Inside the shredder, powerful steel teeth grab and tear the metal. Every shred is a deliberate act to dramatically increase the surface area, exposing hidden contaminants. This initial brutal sorting shakes loose paper labels, plastic liners, and years of accumulated grime, which are immediately separated. What was once a tangled mess emerges as a stream of uniform, bite-sized pieces, ready for refinement. The shredded aluminum now faces a trial by fire, but a controlled one. It enters a massive, rotating hot air decoding drum where temperatures climb to 500 degrees Celsius. This isn't melting, it's thermal cleaning. The intense heat vaporizes paints, lacquers, and any remaining plastic coatings, turning them into gas and ash without oxidizing the metal. It's a critical step, as these impurities would contaminate the final alloy. To protect the environment, a powerful vacuum system captures all smoke and particulate matter, channeling it through filters before releasing clean air. What exits the drum is bare, shimmering aluminum, but the purification isn't over. Heat has dealt with the coatings, but stubborn, greasy residues can still cling to the metal, oils and lubricants from its previous life. To tackle this, the scrap is plunged into a turbulent chemical bath. This could be a powerful detergent or a specialized solvent, precisely formulated to dissolve organic compounds without damaging the aluminum. Think of it as the world's most intense load of laundry. After the chemical wash, a multi-stage rinsing process is essential. High-pressure jets of water blast away any remaining detergent and grime, ensuring the metal is chemically pure. What emerges is almost unrecognizable. The grimy pile is now a gleaming mound of high-purity aluminum flakes, uniform and pristine. This isn't just clean scrap, it's a carefully prepared raw material engineered for quality. The long, arduous cleaning process is complete. Now, this purified metal is ready for the heart of the factory. It's time to face the fire. This is the fiery heart of the factory. The melt deck, loud, blindingly bright, and blisteringly hot. It's an environment of extremes, where solid aluminum begins its dramatic transformation back into a liquid resource. These aren't ovens, they're colossal cauldrons that hold thousands of pounds. More accurately, they are massive, reverberatory furnaces, engineered to contain the immense energy needed to liquefy metal on an industrial scale. The process begins with the charge. A charging machine feeds the clean, shredded aluminum. Much of this is post-consumer scrap given a second life, so it's crucial the scrap is free of contaminants that could compromise the final alloy. The door seals, the burners roar to life, unleashing millions of BTUs of raw thermal energy. The temperature soars to around 1400 degrees, well above aluminum's melting point of about 1220 degrees. This superheating ensures a rapid and uniform melt. Inside, the transformation is mesmerizing. Solids glow, sweat, and collapse into a silvery pool, dissolving into the liquid bath. As the metal liquefies, impurities and oxides float up as dross, forming a thick, crusty layer on the surface. Removing it is critical. Skimming is demanding and dangerous. Skill, strength, and respect required. A worker in protective gear uses long steel rakes to carefully separate the waste from the precious molten metal. Even this waste isn't truly wasted. Collected dross can still yield trapped metal later through a secondary recovery process, maximizing efficiency. With the bath clean, it's time for alchemy. A pinch of alloying, silicon, magnesium, manganese, improves strength, castability, and finish. Each addition is a precise prescription, tailoring the metal for its final purpose. But is the recipe perfect? Samples are analyzed to confirm the recipe. A spectrometer verifies the exact chemical composition, acting as the ultimate quality control check. Only when pure, perfectly mixed, and at target temperature, does the metal earn its next step, casting. This molten river of engineered metal is now ready. The glowing metal transfers into an insulated ladle. A crane or specialized forklift ferries this liquid fire with care. For cookware, we cast thick round discs, slugs. The pour must be steady, complete, and controlled. The metal solidifies from the outside in. Water-cooled molds speed and strengthen the structure. Minutes later, solid, but still scorching, discs roll out. They cool as they travel down the line. They don't look like pots yet, but all the potential is there. Next stop, shaping. A haul of hydraulic heavyweights. Hundreds of tons of pressure on tap. The process is called deep drawing. One stroke forces metal to flow and stretch into a pot-shaped cup. Too much, it wrinkles or tears. Too little, it won't form. Lubricants and dialed-in settings keep the flow controlled. Large pots often require multiple draws to reach full depth. On a spinning lathe, the rim is rolled, smooth, strong, and safe. If needed, a press forms a clean spout. Other details are stamped in sequence. Our flat slug is now unmistakably a pot. Rough, unpolished, and ready for finishing. Power and precision in perfect balance. Next, the makeover. First stop, trimming the rim flat and true. The scrap ring? Back to recycling. Nothing wasted. Handles are cast or stamped separately. High-powered riveting secures a rock-solid connection. Built to carry a pot full of dinner, year after year. Coarse defined wheels erase marks and raise a mirror finish. Non-stick interiors are prepared and coated here. Every pot faces strict inspection. Finish, dimensions, and handle strength. Washed, labeled, and boxed. Ready to ship. It begins with an intense, controlled inferno. A torrent of molten aluminum, reclaimed from its previous life, is poured with precision. Here, fire, force, and finesse converge, transforming discarded metal into the raw material for new, durable cookware. But the real magic isn't just in the metal's transformation. The most profound reason this matters can be summed up in a single, crucial word: energy. Creating aluminum from scratch requires mining bauxite ore, then using colossal amounts of electricity to smelt it. Recycling skips that entire energy-intensive journey. It uses a staggering 95% less energy, one of the most dramatic efficiency gains in modern industry. Let's bring that number down to a human scale. The energy saved by recycling just one aluminum can is enough to power a television for 3 hours. That small act has a real, measurable impact. Enough energy to keep an LED bulb shining for over 20 hours. Now, scale that up. The savings become astronomical. Recycling just 1 ton of this metal saves about 14,000 kilowatt hours of electricity, more than the average American household consumes in an entire year. On a national scale, we are effectively powering millions of homes with our recycling. This efficiency has a powerful ripple effect. It reduces our reliance on destructive mining and avoids releasing potent greenhouse gases from primary smelting. And perhaps most remarkably, aluminum is infinitely recyclable. It can be melted and reformed again and again without any degradation in quality, creating a true closed-loop system. The very atoms that form this pot might have been a soda can, a window frame, or even part of an airplane. They live on in a near-endless cycle of rebirth. This circular economy doesn't just conserve resources and slash pollution, it fuels a robust industry, creating stable jobs in collection, processing, and manufacturing. It's a powerful example of how smart design and conscious choices can build a more sustainable future. Boxed and ready, hundreds of pots wait to ship. They'll travel to stores, big box aisles, and online orders, unwrapped, washed, and ready for a first meal. Boil, simmer, comfort, an everyday workhorse at the heart of home. From feasts to quiet dinners, it anchors the table. Most never see the claw, the furnace, or the press, or the people behind them. They just know it as their favorite pot. But now you know, it's more than cookware, it's renewal made real. So, who's hungry?